Hello and welcome to this Xilinx Quick Take video, which will focus on an overview of the Vivado constraint system. We'll cover some high-level concepts for a big picture view of how Vivado handles constraints. There will be follow-up videos breaking down topics in finer details, so please look for those if you're looking for more specific information. The agenda for this presentation is as follows. First, we'll give you a little introduction to Xilinx Design Constraints, or XDC. Then we'll talk about what types of constraints are covered and how they're managed in the project environment. I'll keep the slide content to a minimum and spend a few minutes showing you the Vivado tool in action and wrap things up with some pointers for additional information. Vivado supports XDC, which is a new constraint file format. XDC is an acronym for Xilinx Design Constraints, and it's based on an industry standard open source specification from Synopsys called SDC for Synopsys Design Constraints. SDC is purely for timing constraints, and we needed additional constraints for physical constraints, hence the name XDC. XDC is a common constraint language throughout the Vivado flow through synthesis and implementation, and it's used as a sign-off constraint format for designs. XDC is based on another industry standard scripting language called TCL, which stands for Tool Command Language. The way to think of it as XDC is a superset of SDC, and our TCL scripting language is a superset of XDC and includes a very comprehensive scripting and batch mode automation capability. Think of XDC as the Vivado equivalent of the UCF file. However, Vivado does not support UCF. There will be specific videos to help people convert UCF to XDC, so please look for those. There are two basic types of constraints, timing and physical. Timing constraints are based on SDC and include clocking, input, and output constraints, and exceptions which override the basic constraints. Physical constraints are everything that isn't part of the SDC spec. I/O constraints and floor planning constraints are the most common examples. Constraints can be added to projects, or they can be used in pure batch mode compilation scripts. The important thing to know about constraint files is that they're managed by the Interactive Design Environment, or IDE. The IDE has loaded the design, read the constraints, and presents it to you in the tool for analysis. If you modify something that affects a constraint, it happens in memory, and what you see in the tool reflects the state of the design. When you click to save, that is when the constraints are saved back to the file location in the hard disk on your project. This is important to understand. Vivado knows the context and the state of your design and gives you graphical access so that you can analyze the design, project, and the device. The default extension for the constraint file is XDC, though this can be overridden manually if you wish to use a different file name. And of course you can have any number of constraint files, but you need to remember that the order is important and you can control that. You have the option to write constraints for both synthesis and implementation, or break it up and have separate files for each step, which allows you to change constraints for different phases of the flow. In Vivado, the target constraint file is the file where new constraints are written to if you have multiple files. IP cores in the IP repository can deliver XDC files as well, and users can write their own, and they can be scoped to the level of hierarchy, allowing you to write standalone constraints for IP during development that can be used in implementation of larger designs. Vivado also supports multiple constraint sets, which allows experimentation with different settings of constraints and strategies, a topic which is covered in greater detail in another video. There are a few recommendations that need to be made clear for all designs. First of all, it is critical that you verify constraint correctness prior to running the implementation tools. Constraints are applied to synthesis as well, but the implementation tools are more sensitive to inputs. The placer and the router are heavily timing driven, and it can make a big difference in the tool results. So we recommend you always validate constraints in the post-synthesis design state at a minimum. You should verify and eliminate all errors and critical warnings. When you open the synthesis netlist, it reads the design and applies the constraints. If there are any errors or critical warnings, you will see a pop-up dialog informing you of this. You can also view the Messages tab to review these. We recommend you spend time using the reporting and analysis tools to validate timing before you attempt to invoke the implementation phase. Verify constraint correctness and coverage. More details will be available in specific reports and analysis features in the Vivado user guides and other videos. At this point, I'll give you a very brief demo of Vivado. First, I'll click on the Open Synthesize Design button in the Flow Navigator. This opens a post-synthesis netlist and applies the constraints from your XDC if you have one. At that point, your design is in memory and you can run reports and queries live using the IDE. I'll expand the Sources tab and view the XDC constraint file for this example design. We see 2 clock constraints and a number of I/O constraints. This is the source file in the project that was read in and applied to the netlist. When you interact with the IDE, you are working with the in-memory representation. When you save the project, those changes are saved back to the source file. Now I can run a timing report summary. This gives you a lot of information about constraints and constraint coverage. If I bring up the timing constraint editor, I can modify and add constraints to the in-memory model. In this case, I can add input delay constraints. When I click to save the project, I see that my constraint file is now stale. Reloading it with what I saved to disk shows the new constraint added to the end of my constraint file. I can rerun the summary timing report and see the updated timing report for the constraints I added. I can also debug and correct conflicting or missing constraints and apply exceptions. All of these topics will be covered in greater detail in individual constraints in the Vivado user guides as well as other videos. Now my design is out of date, both synthesis and implementation. If I rerun the flow, my constraint updates are applied to the new flow. So I can use the IDE analysis capability to query my constraints, debug, and correct them, either with the timing constraint editor or the source editor. You can do this incrementally with the in-memory model, clean up constraints, and then launch the implementation flow. We just saw a brief demo of the constraint system in Vivado IDE. If you're interested in additional details, you can go to Xilinx.com and look at the documentation and tutorials which are available there. We have additional videos on various topics, including more specific presentations on timing and physical constraints. Thank you for watching.